and then we'll take some notes on this section. So 11.6, volumes of prisms and pyramids. And we'll get this started. So we're talking about volume, and if we get a chance when we get back from spring break, we'll talk about surface area. But this little picture is showing how different companies, they try to figure out how they can use the least amount of packaging based on the volume. So the volume of a toothpaste container, and that's how much stuff it can fit in there. And they try to make packaging so that it's the most profitable. And so they do that using volume. We're going to have 3 standards that go with this. Volume's a pretty big one for geometry. And then we're going to get into this part. So first of all, the first shape we have is a prism. And I'm going to talk to you just about what the definition of a prism is. And so for a prism, it's more of your boxy type shape. And a prism is going to have 2 bases that match. And those bases are always parallel to each other. And then all the other shapes are a form of a parallelogram. So this would be a prism. Also, I want to get this one right here is a prism. The bases on the ends are triangles. And so then every other side is a form of a parallelogram. This would be a prism. It's got to have 2 bases. 2 bases are parallel to each other. This base is a hexagon. And then all of these other sides are rectangles. And then even what we would think of as a cube, that's also a prism. It's got 2 bases that are parallel, and then all the others are forms of a rectangle. And we name our prisms by whatever shape is on the end. So this would be a square prism. This would be a hexagonal prism. This would be a triangular prism. And this would be another square prism. So you look for the box, you look for the 2 sides that are parallel to be your bases, and then that'll help us know it's a prism. So we're going to find the volume of prisms today, and we're going to write this in our notes. So volume of prisms, and we're going to put V equals, okay, it is very important that you put a big capital B and a lowercase h, because we've had a lowercase b before, and that is different. And I'll explain that here in a second, but it's very important that that is a capital B. And the capital B represents the area of the whole base. And the H represents the height of the whole prism. And we're going to practice this. So when we go to find the volume of this shape right here, the big B is the area of the base. So we would find the area of a square. We would find that whole area, and then we would multiply it by the height, and that's going to be your distance between the 2 bases. So our height is of the whole prism. The big B is going to tell us our area of this whole shape right here. And so that's what we'll practice today, figuring that out and getting into ones that are a little bit tricky too. Okay, I think we all have that one written down. Okay, now I know that you might not all be good artists. I am not, but I'm going to have you attempt to draw that in your notes, because I'm starting off with the one that is the trickiest one. For some reason, every year when we do volume, this is the most missed kind of question. and this is a triangular prism. So I'm starting us right off with the one that's the trickiest. So try to draw it because I want us to have a reference to look at. We're starting off with this one with some dimensions, and then we'll solve this together. Only you have to look at your picture, so it doesn't have to be perfect. Okay, so here's probably why one of the things that people mess up on this. People pick the wrong base. So the base is not always what is like touching the ground. So when they look at this, they're like, oh, this shape right here is touching the bottom, but that's not our base. Because with a prism, the base represents the two sides that are parallel to each other. And so it is actually a triangular prism that's on its side. So it's kind of looking like this, which means these two triangles are the two bases. So that's a base and that's a base. They usually put the triangular prisms on their side. So that's, I think, why people miss this one. But the triangles are the bases. So now, knowing that, that'll help us with our formula. So off to the side, I'm going to rewrite our formula. Okay, now I'm going to write it in another little part too. In place of my area of the base, I'm going to put this parentheses because I've got to put a whole little formula in place of that big B. My base is a triangle. Does anybody remember the area formula for a triangle? 1/2 base times height. So if I look at this triangle and I do 1/2 base times height, that's going to be 1/2. The base of the triangle is 12, and the height of the triangle is 10. So in place of that big B, we have to put a whole other little formula because it's the whole area formula for the triangle. Then, in place of the height, this is the other part that's tricky. Remember, it's not how high it is just from the ground. This is on its side. So your height is if that prism were standing up, face straight up, and it's the line that would connect the bases. Do we have a number up there that connects the two triangles? 11. So this is our actual height of the prism because remember it's on its side right now. So in place of the height of the prism, I'm going to put 11. Now we're going to multiply these numbers together. So with a calculator, this is really easy. You can just do 1/2 times 12 times 10 times 11. And this is going to get us our answer. Just multiply all four of those numbers together. 1/2 times 12 times 10 times 11. Does anybody already have that one? When we multiply all those together? 660, good. So that's our volume. And then to label volume, so we're going to put centimeters, and volume then is always cubed. So this triangles, be careful. These are just the ones that people miss, and we've got our tricky one out of the way right now. But we'll have another one a little bit later. Before I erase this one, any questions before we try the next one on this? Okay, I'm going to erase it, and we're going to try another one. Okay, this one I'm not going to make you draw. It's kind of a weird shape. This one is standing up, kind of upright like it should. The two bases are trapezoids this time. So this would be called a trapezoidal prism. What I am going to have you draw is the trapezoid that's on the bottom though. So for the trapezoid, these two things are our bases of that trapezoid. So let's take a minute and let's just draw that part. We got our bases are 2 and 4. And then our height of that trapezoid is 5. So we'll just draw the base for when we get to that part. And then we've got the prism over off to the side to help us out. Okay, so our formula is big B times H. But in place of this big B, we've got to put the whole area formula for the base. So we need to put the whole area of the trapezoid. So up here, I'm going to put a little reminder. This is how we find the area of a trapezoid. So we've got to figure this out and put that all in place of big B. So I'm going to put 1/2. Okay, now just looking at the trapezoid, what number in that trapezoid represents the height of the trapezoid? In this shape right here. What's our height of the trapezoid? 5, yeah, in that trapezoid. Okay, then add our bases together. So what are the two numbers that we're going to add together in the trapezoid? 2 and 4, good. So for the big B, you're not looking at the overall prism. You're just looking at the base and figuring out that area. Okay, then for the H, this height right here, what's the height of the whole solid, the whole prism? How tall is that whole thing? What number up there represents its height? 8, yeah. So for the big B, just focus on one of the sides, but then for your height, you're figuring out for the whole shape how high it is. Okay, now I'm going to do one thing, and then I'll have you plug it in. We've got 1/2 times 5. I'm going to add those together, so it's a 6 times 8. Now plug that in. Maybe. Oh. Okay, so then if we multiply all these together, who's got a number for us? 1/2 times 5 times 6 times 8. 120. And then we're going to label it centimeters cubed. So you're never going to put just one number in for your big B. Your big B is going to represent a whole little area formula on itself. Okay. Okay, questions there before I move to the next part? Okay, next up, we're going to get a pyramid in the mix and talk about a pyramid. And let me show you this little clip so you'll understand where the formula is coming through. So that blue shape is a prism, and they're breaking it up into pyramids. So in every prism, you can break it into 3 pyramids. And that's going to explain our formula here in a second. But I'm also going to show you this. Now, if I had way more time and we had time to do experiments, I would get some water. Here's a prism, like what we were just talking about. Here's a pyramid. If I filled this pyramid up with water, how many times do you think it would fit into this? Twice? More? 3 times. It would be exactly 3. So for every prism, it takes 3 pyramids to fill it up. So then the formula for a pyramid is going to be a third of what the prism is. So let's write this in our notes. Volume of pyramid. And it's going to be 1/3 big B times H. So it's the same base, the same as a prism, except now we're taking 1/3 of it because it has 1/3 as much volume as what its matching prism would be. And we're going to practice that. So the big B still stands for area of the base. But now when we have pyramids, let me show you a couple. The pyramids only have one base. So here's a pyramid. You've seen them before. They have big ones over in Egypt, but they have one base, and then everything else meets at a point. We name our pyramid by the shape on the base. So this would be a square pyramid. This would be a triangular pyramid. And when we go to find the area of the base, whatever shape's on the bottom, that's what we find the area of. So we're going to try this out. Hi. Yeah, yeah. Okay, so as you're drawing it, by looking at kind of the dimensions, there's a rectangle on the bottom. So this would be called a rectangular pyramid. And we're going to find the volume of this here in just a second. The height, it's going to have that 90-degree angle, which we see that kind of going down through the center. Okay, so I'm going to keep my 1/3. Okay, then in terms of the big B, I'm going to put parentheses right there. The base of this shape is a rectangle. Does anybody remember how we find the area of a rectangle? You learned this way back in middle school. Base times height. So if we look just at this rectangle right here, and we did base times height, it would be 9.5 times 8 of just that base. And then the height, so this is the height of the whole pyramid. What's the height of the whole pyramid? What number is that? 9. Okay, then we just multiply all these numbers together. 1/3 times 9.5 times 8 times 9. It will be a whole number. What do we get? 200 and what? 28, thank you. So 228, and then I'm going to label it, man, these have all been centimeters. Centimeters cubed. And there's how we do that part. Questions on that one before we try another one? Okay, next one we're going to try then. We're going to try this little combination. I'm not going to have you draw this. We'll break it apart without having to draw that, but it's two shapes in one. So the bottom of it is kind of like a really tall, narrow prism. And then the top of it, can you see how it's a triangular prism but on its side? So it's going to be two prisms that we add together. So here's what we'll write in our notes, because when we start getting shapes like this, it starts getting kind of messy fast. So for this bottom prism, the base of it is a rectangle. So to get ourselves organized, I'm going to put rectangular prism. And then the top of this is a triangular prism. So we're going to find the two of them and add them together. So the bottom shape is a rectangular prism, and the top shape is a triangular prism. We'll find the volumes of each of them separately. Okay, so they're both prisms. So it's going to be base times height, and then this one's also going to be base times height. Okay, for this big B, it's a rectangular prism, so the base is a rectangle. So here is that shape right there. That's the bottom of it. And if I want to do the area of that shape, it's going to be 5 times 12. So in place of big B, we're going to do 5 times 12. What's the height of that whole bottom prism? 8. So it's going to be an 8 here. Okay, so I'm going to leave that for right now. We'll come back to you. Okay, now the triangular prism, this is where it gets kind of goofy. Triangular prisms are just always the trickiest. First thing, don't forget that the triangles are the ones that are actually the base. So this is a prism, the top prism is on its side. And so what I'm going to have you do is, we haven't drawn the whole shape, but I'm going to have you draw this base. And it tells us that these two sides are the same and they are both 4. So that triangle is the base of the top prism. We have to find the area of this triangle for the big B. Okay, well, look at the picture, and if you look closely, you're going to know how long this line right here is. Can anybody figure that out? What's this line? 5. So that's good. Okay, but we need the height of this triangle. And so this is where we're going to have to do some extra work to find the height. It's not going to be trig that we have to do, but does anybody know what other thing we have to do in order to figure out our height? Pythagorean theorem. So if I look at this on that green part of the triangle, or what's the bottom of the green triangle going to be? Good. So we've got to do Pythagorean theorem to find this x. So it's going to be x squared plus 2.5 squared equals 4 squared. That's going to be x squared plus 6.25 equals 16. I'm going to subtract 6.25. Okay, then I'm going to need some help with this number. We need a square root 9.75 and get a decimal, I know. 3.1, okay, thank you. So then x is 3.1. Okay, that means if x is 3.1, that's our height of the triangle. So that was what took the most amount of work, which is sometimes why triangle prisms are harder too. Okay, so we had to do Pythagorean theorem with that end of the base to get some numbers. Okay, now to organize it, the area of the base. So I'm going to put parentheses. So I need the area of that triangle. 1/2 times the base of the triangle times the height of the triangle, which we just found through Pythagorean theorem is 3.1. So that's my area of the base, the area of the triangle. Okay, now the height of the whole prism. So remember that this top prism is on its side. And so the height is actually the line that connects the two bases. It's on its side. Which number up there represents the height of this triangular prism? 12. It connects the bases. So in place of that, I'm going to put 12. Okay, now we got to put all these numbers together. So let's start with the rectangular prism. 5 times 12 times 480. Okay, then let's do the next one. 1/2 times 5 times 3.1 times 12. 93. Does it round to that pretty good? Okay, now don't erase it because it's not exact, right? Am I right in that, Ben? Okay, don't erase that when you get this in there, and then just do plus 480, and it should still round to something nice, but I just wanted us to practice for our computer homework. And when we add those together, we're going to get, hopefully you're getting 573. And then we'll label this another centimeters cubed. And that's how we do that one. So be methodical with these. It's kind of like once you kind of get used to them, they're not horrible. You just have to stay organized on your paper as we do these. We've got another one to try, but I want us to just make sure that before I erase it, there's anything we need to ask, we can ask. But here's our first combo. Anything up there you want to ask about? Okay, we're going to try another combo. Okay, this one is the Washington Monument. It's a little replica of that from Washington, D.C. And so what we've got going on, the bottom part of this is a square prism. So it looks like this for the bottom part of the Washington Monument. And then at the top of it, we've got a square pyramid. So we're going to find both of those volumes and add them together. And again, we're going to keep ourselves organized because we've got two different shapes. So instead of drawing it, let's just kind of write out what we're finding. So let's put, we've got a square prism plus a square pyramid. We'll find each of these on their own. Looking at the numbers. Okay, let's start with the square prism. So the prism formula is big B times H. So we need to find the area of the base. The area of our prism is this square right here. And to find a square, we just multiply these dimensions together. Can you tell from the picture what both of these dimensions are going to be? They are, because it's a square. So these have to be the same. Now, can we tell what those are going to be from the numbers up on the picture? What's one of the sides? 6.5. So our base, in place of our big B, when we do the two things multiply together, it'll be 6.5 times 6.5. Because it's a square, those have to be the same. Okay, now the height of the whole prism. So it's standing up like this. What is the height of that whole prism part of this monument? What number up there represents the height? $36. Thank you. Okay, so that'll take care of our prism. Now let's talk about our pyramid. Okay, for a pyramid, it's 1/3 big B times H. So we'll have our 1/3. And then, in place of big B, we're finding the area of this square right here. So again, these two sides have to be the same. What are both of those sides? What number up there represents what both of these sides are? 6.5 again, because don't they fit on top of each other? So the two squares will be the same. So just to kind of say that in another way, this square for the prism was 6.5 by 6.5. It matches exactly on that square, 6.5 by 6.5. So we're going to put 6.5 times 6.5. Okay, now we need the height of the pyramid. What's the height of the pyramid up until the vertex? It's a number we've said many times before, 6.5. Okay, now let's type this in our calculator. First one, do 6.5 times 6.5 times 36. Let's get that number. 6.5 times 6.5 times 36. And somebody tell me when you get this. 6.5 times 6.5 times 36. 15.1. Okay, now let's get the pyramid. 1/3 times 6.5 times 6.5. Oh, 1521. Okay. And was that even then? Perfect. I like that even better. Thank you. All right. 1/3 times 6.5 times 6.5 times 6.5. Say that again. 91. Okay. Okay, then add those together. And what are we going to get for our final answer? Did I add that together right? Check my math. Let's see if I added those together. Okay. That, and then I'm going to label this. So we are in inches cubed. And there's my volume. So that little model version of this, add them together, and then you'll get that. Okay, how are we feeling so far? Okay, the key to these are just to, don't rush through them. You'll forget something little if you rush through it. So take your time, keep yourself organized. Couple hints about the big B so you don't mess the big B up. Make yourselves parentheses and put the whole area formula in there, because then you'll be able to catch yourself if you're making a mistake. And then the other thing is with triangular prisms, these are the ones that are hardest for people to see. Your triangles are your bases. So a lot of times they've got it on its side. This is your base, and then your height would be right here. So just be careful on those. Okay, so that's all we need to discuss today. Your homework for this is on McGraw-Hill. So that means you need to be really careful about all your decimal usage and that kind of thing. But you got a couple problems on there for homework due tomorrow. And then tomorrow in class, we'll review these and the ones that you did Monday, the ones you did yesterday in class. So we'll get ready for our quiz on Thursday. So we've got that going on. And you got a couple minutes. You can maybe get a question or two done for this week.